Hello, today we're going to take a look at some conversions within the metric system. Listed in front of you are some of the basic metric prefixes that I will expect you to know. In the middle, you'll notice you have your basic units. And the basic units of measurement we will be working with are the gram, the liter, and the meter. To the right of that, we have all the small prefixes that can be denoted with these negative exponents. So all of these represent very small metric quantities. To the left, you have your larger metric quantities, and you can tell they're larger because you have the positive exponents on the power of 10. So today we're going to look at one specific way of converting within the metric system, and it's a process that is called decimal bumping, and I'm going to list the steps for you. So with decimal bumping, you're going to follow 4 steps. The first step is to locate the decimal in the number you are given. In the second step, you're going to locate each prefix in the conversion in the diagram up above. Third step, you're going to subtract the 2 exponents that are related to these prefixes. And then finally, you're going to use that result to move the decimal the correct number of spaces and also the correct direction, which will be determined by step 3. So let's take a look at an example. So in this example, we are needing to determine what dimension are we working in here, or what is our basic unit of measurement. So if we look at L, L is the abbreviation for liter. So we're looking at converting 15 liters to the KL. K, notice, represents kilo, so we're converting into kiloliters. So it's important to start getting comfortable with these labels. Now, the first step in decimal bumping is to locate the decimal in the number. That's pretty straightforward on this problem. 15, when we look at that number, the decimal's always behind the number, so it's after the 5. So now the next step says to locate each prefix in the diagram. Well, the first one here doesn't have a prefix, it's your basic unit. And you might recall that for the basic unit, your exponent here is going to be 10, and that's the number we're going to want to focus on. For the kilo, we are looking at an exponent of 3. So again, we're locating the prefixes, but what we're going to focus on are these exponents that are a part of that. So step 3 says to subtract the 2 exponents, and we want to make sure that we do those in orders. I am moving from liters to kiloliters, so I want to start with the exponent for liters, which is a 0, and I'm going to subtract from that the exponent for kiloliters, which is the 3. Now this involves dealing with some integers, so I'm going to rewrite 0 minus 3 as 0 plus negative 3, which will give me a result of negative 3. Now this value tells me exactly what direction and how many spaces to move the decimal to do this particular conversion. So let's take a look at 15. Now remember, the decimal was right here after the number, so the 3 and the negative tells me I'm going to move to the left because I want to think of this like a number line, and on a number line my positive values are to the right, my negative values are to the left. So I'm going to move this decimal point 1, 2, 3. Now notice I need to add in a 0 here as a placeholder, and my decimal now moves in front of that 0. And to finish off my problem, I'm going to go ahead and put my answer in the blank up above But remember, with a small number like this, I start with a 0, then I have the decimal, and then 015. So that is the conversion for this particular problem. Now, let's take a look at another example. Okay, so in this example, once again, I want to start by locating the decimal in the number. And again, that is right here, 125, and the decimal comes after that. And then I want to locate the prefix in the diagram. Well, that means I need to understand what the prefixes are. So DM, okay, what does that stand for? Well, the D is up here in deci, and it has a prefix, or a exponent of -1. M and M, what does the M stand for? Well, the M is a meter, and so I've got 125 decimeters, and over here I have an M meter, and an M meter would be a millimeter, and so millimeter has an exponent of 3. So now I'm going to take a look at step 3, which tells me to subtract the two exponents. Now remember, in subtracting, I'm going to start with the decimeter, and that's going to be a -1, and I'm going to subtract from that the millimeter, which is a -3. So lots of negatives here. I need to be very careful. So rewriting it as an addition problem, I get -1 plus +3, which -1 plus 3 is a value of 2. And notice that is a +2. So in order to convert 125 decimeters to millimeters, I'm going to take my 125 that has a decimal point right here, and I need to move it 2 spaces to the right since it's positive. And on a number line, right is always positive. So that's where my decimal will move to. I need to put in 2 zeros here. And so the last thing I need to do is put my answer on the number line. So this becomes 12,500 millimeters. So this is how you use decimal bumping in order to make conversions in the metric system.